Hey everyone, welcome back to the CyberNetters Unix administration course. I'm Andrew Yick, and today we're going hands-on with Linux installation and shell basics. In this session, we will walk through the installation process, explore disk partitions and file systems, and dive into the Unix shell, the command line interface that lets us interact with the system. So, in this video, we'll be going through a live demonstration where I'll show you how to navigate the shell and run essential commands, manage users and system privileges, use pipes, redirection, and built-in help tools, and safely shut down and reboot your system. By the end of this video, you have a solid understanding of how to set up and interact with a Unix-based system, which sets up the foundations for more advanced sysadmin tasks. Let's get started. Also, make sure to watch the installation of Unix video if you haven't, if you want to install like a VM on your computer so you can follow along with the video. Okay, so when installing a Unix-based operating systems, there are three main installation methods, which are each suited for different environments and need. So you would use CD DVD install, where the OS is installed from a bootable CD or DVD. It is simple and reliable, but it requires physical media and may not always have the latest update. This is usually the traditional method. So for network install, instead of using the physical media to install it, like CD, DVD, the OS is installed directly from an online repository. This makes sure that you get the latest software and security updates, but requires a stable internet connection. You also have the container-based installation, which instead of installing a full OS on a hardware, the containers allow you to run lightweight, isolated environments using tools like Docker or Podman. This method is widely used for development and cloud-based applications. Before installing a Unix-based system, there are a few things you should consider to keep in mind to ensure a smooth setup. Very important. So, the first one is the disk and file system configuration. This is the most important decision because it cannot easily be changed later. So choosing the right partitioning scheme and file system ensures stability and performance. Other key settings include that you can most likely change later is root password, which is the most privileged account in Unix. Your root account must be secure. Also, your timing configuration. Setting the correct time zone ensures that you have accurate logs and scheduled tasks. You also have your network configuration. So whether you're using DHCP or static IP, proper setup ensures connectivity. And then software and daemons to install. You need to choose your right services upfront to avoid an unnecessary bloat. So planning these things ahead of time prevents security risk, performance issue, and reinstallation headaches later on, which all of us would not like. When setting up a stick system, it is important to understand different hard drive interfaces as they determine performance, compatibility, and naming conventions in Linux. So first we have the PATA or parallel ATA, which is the older technology. We also have SATA or the serial ATA, which is the most common interface for HDDs and SSDs today. We also have the NVMe's, which is the non-volatile memory express, which is designed for high-speed SSDs. We also have this SCSI and the SAS, which is the serial attached SCSI, which are often used in servers and enterprise storage. Each of these technologies that I mentioned have different speeds and usage advantages, but modern systems such as SATA or NVMe use for storage. A hard drive for Unix or Linux is divided into one or more partitions, which allows different sections of the disk to be used for specific purposes. So each partition in here must be formatted with a file system before the OS can use it. One of the more older partitioning schemes is called the MBR or the Master Boot Record, which has a maximum storage limit of 2 terabytes, making it unsuitable for larger modern devices. Newer systems such as use GPT or the GID partition table, which supports much larger drives and more partitions. Choosing the right partitioning scheme is crucial for storage management and system performance. Newer systems use UEFI firmware instead of the traditional BIOS, which allows for better security, faster boot times, and support for modern hardware. So with UEFI, most systems use the GPT or the GID partition table instead of the master boot record. GPT supports much larger disk spaces, which is over 2 terabytes, which is a lot, or even up to exabytes, which makes it ideal for modern storage. So in Linux, drives and partitions follow a specific naming convention. So the whole disks are usually using dev.sda, sdb, or sdc, and then the partitions are letters followed up by numbers, so SDB1, SDB2, SDB3, and so on. Understanding these naming conventions is very important when managing disk partitions and storage in Unix or Linux. So, when setting up a Linux system, you would need to define partitions for organizing storage. At a minimum, two partitions are required, which is the slash or the root, which is the main partition where the operating system and all files reside. And then you have the slash boot, which stores all boot related files in the kernel. Additional partitions can be created based on system needs, like the following: slash swap, which is used for virtual memory and is now optional due to large RAM availability, and it was like one of the required ones previously. USR holds all systems, applications, and libraries. Slash home stores all users' files and personal settings, and slash var is used for system logs, caches, and other changing data. The reason why proper partitioning is important because it helps with performance, security, and system recovery. So think of the Unix file system like a tree, with the root or the slash at the base and everything branching from it. So each directory, as you can see in the slides, has a specific purpose. Slash bin is essential system commands and binaries used by all users. Slash sbin are system binaries, which are mainly used for administrative tasks. Slash etc are configuration files for the system and applications. Slash dev are used for special files that represent hardware devices. Slash proc are virtual files that provide system and process information, and slash user installs applications and system utilities. Slash home is for personal directories for each user. Slash var is for variable files like log caches and print jobs. Slash temp or TMP is temporary files that are automatically cleared after reboot, and then you have the slash lost and found, which stores recovered files after a system crash. So understanding this is very important and it's key to managing and navigating Unix-based system efficiently. So I would recommend you to try to memorize this as soon as possible. So later in this course, when we talk about like the different things inside of each of these like branches, you'll understand what each of them is and what we're talking about. When setting up disk storage in Unix or Linux, you have two main partitioning options. The first one is by using standard partitions, which is the traditional method where partitions are fixed in size and cannot be easily modified. And then you have the LVM, which is the Logical Volume Manager, which is a more flexible and dynamic approach that allows you to resize, move, and manage disk storage effectively. While LVM is more complex to set up, it provides better scalability and management compared to traditional partitions. So let's talk a bit about how LVM works. So it works by grouping physical storage into logical volumes, which makes it easier to adjust storage without disrupting the system. It is useful for servers and enterprise environments where storage needs might frequently change. So in Unix or Linux, the terminal, shell, and kernel work together to allow users to interact with the system. What a terminal does is it's simply a channel that allows users to log into the system, either locally or remotely. Think of it as a doorway to the OS. The shell is the user interface that processes commands and passes them to the kernel, which is the core of the operating system that is responsible for managing hardware and processes. And then we have the bash shell, also known as born again shell, which is the default and most widely used shell in Linux, which provides powerful scripting and command line capabilities. Since Linux supports multiple terminals, you can open different sessions and run commands independently, whether on a local machine or on a network using SSH. Let's do a deeper dive on what the shell in Unix is. The Unix shell, in this case, is the command line interface that allows users to interact with the system. That acts as a command parser, which takes the user inputs and executes the instructions. So with the shell, what you can do is you can start, stop, and manages processes, work with files and directories, and execute system commands. Commands can be entered manually for one-time tasks or written into scripts for automation. Shell scripting is an essential skill for system admins, which allows them to simplify repetitive tasks, automate system management, and enhance efficiency. Later in this course, we will dive deeper into shell scripting, which covers how to create, structure, and execute powerful scripts to manage Unix systems effectively. So, in Unix and Linux, there are three types of shells, which each of them serves a different purpose. So, the login shell starts automatically when a user logs into the system. It is defined in etc password and it runs startup scripts like login, CSHRC, or profile, which configure the user's environment. Once a session is closed, the user is logged out. And then you also have the interactive shell, which is the non-login shell where users manually enter commands. It doesn't process full startup scripts, but it allows real-time interactions with the system. And then you have the non-interactive shell, which is mainly used for executing scripts, and it doesn't require user inputs and inherit environment variables from the parent shell, making it perfect for automation and scheduled tasks. Understanding these shell types are important for managing sessions, writing scripts, and automating system tasks efficiently. When setting up disk storage in Unix or Linux, you have two main partitioning options. The first one is by using standard partitions, which is the traditional method where partitions are fixed in size and cannot be easily modified. And then you have the LVM, which is the logical volume manager, which is a more flexible and dynamic approach that allows you to resize, move, and manage disk storage effectively. While LVM is more complex to set up, it provides better scalability and management compared to traditional partitions. So let's talk a bit about how LVM works. So it works by grouping physical storage into logical volumes, which makes it easier to adjust storage without disrupting the system. It is useful for servers and enterprise environments where storage needs might frequently change. Linux and Unix support multiple shells, each with different features and capabilities. These should use like Korn shell, use command history and tab. The bash shell is the most widely used shell and it's standard on most Linux systems. The CSH is similar to bash, but it has enhanced auto-completion and customization, and the fish is a modern, user-friendly shell with smart suggestions. As you can see, each shell has its strengths, but bash remains the default for most Linux distributions. Users often prefer a graphical desktop environment. Linux runs on a GUI section line interface needed. To access a pure terminal section, use the shortcut Control Alt F2, which brings you to a text-based terminal independent of the graphical desktop. You can switch back to the GUI with Control Alt F7 or another function key, which depends on the system. One thing to note is the command prompt. Regular users see a $sign at the prompt, and root or the super user sees a hashtag which indicates full system control. Knowing how to navigate between the GUI and the terminal nodes is essential for troubleshooting server management and system administration. In Linux, meta characters are special keyboard characters that the shell interprets in a unique way. One common example is the dollar sign, which tells the shell the following text refers to a variable stored in memory. For example, you can use echo $home. This prints out the current user's home directory. Since meta characters have special meanings, you should avoid using them in file names and commands unless necessary. If you do need to use them literally, you can wrap them in single quotes to prevent interpretation. For example, compare these two commands. Mastering meta characters is essential for working efficiently with the shell and scripting. So in Linux, the manual pages, also known as the man pages, are the most common way to access documentation or commands and system functions. So to view the manual for any command, simply type man and then the command. For example, you can do man ls to display the documentation for the ls command. And each man page is categorized into sections, such as page 1 has all the user commands, page 2 has all the system calls, page 3 has all the library functions, and page 8 has all the admin commands. So if you want to search for commands by keyword, use man k and then the keywords. Or you can use a propos and then the keywords. This can help find related commands if you're unsure of the exact names. Understanding man pages is important for troubleshooting and learning new Linux commands quickly. In addition to man pages, Linux also provides GNU info pages, which were originally intended to replace man. So unlike man, info pages are often more detailed and include hyperlinks to related topics, which makes them easier to navigate. However, not all commands have manual or info pages. So for built-in bash commands, you can use the help and then the command, which is useful for shell-specific commands that don't have dedicated man pages. By combining man, info, and help, you can quickly find the documentation you need to understand and use the Linux commands effectively. In Linux, you can schedule or perform an immediate shutdown or reboot using the shutdown command. To schedule a shutdown, you can use the command shutdown h plus 4, which powers off the system in 4 minutes. To cancel a scheduled shutdown, you can use shutdown-c. And then for an immediate shutdown, you can use run shutdown h now. And then for immediate reboot, use shutdown-r now. Other commands include halt, which stops the OS but doesn't cut the power, power off, which completely shuts down the system, and reboot, which shuts the system immediately. And understanding these commands are essential for safe system management. In Unix or Linux, the superuser account, also known as root, has unrestricted access to the system. You can only log in as root only locally, or switch to another user with su root. But be careful, because the root account has the power to do anything, including delete critical system files with a single typo. That's why they guard the root password like it's the last slice of a pizza at a LAN party. Unlike some systems, Unix does not allow creating root equivalent accounts, but you can grant limited root privileges using sudo, which is managed in etc sudoers using the vi sudo command. Using sudo is the safer way to perform admin tasks without handling out full root access to every user. In Linux, when you interact with the system, data constantly flows between the user, the terminal, and programs running in the background. This happens through three fundamental communication channels, also known as streams. So you first got the standard input, or STDIN, which is how the program receives input, typically from the keyboard. So imagine typing into a chat application and your text is being fed into the program via STDIN. And then you have standard output, which is STDOUT, which is how the program sends normal output, which is normally to the screen. When you open a web page and see text appear, that's like STDOUT delivering the final content to your screen. And then you have the standard error, which is STDERR, which is the um, special output channels specifically for error messages. So if the program encounters an issue, it's where it sends error message through stderr to make sure it's not mixed with normal output. So every time you run a command, the system creates a process in the memory. This process automatically gets connected to these three streams. SD then listens for user inputs, which waits for data to be entered. SD out collects normal responses from the programs and sends them to the screen, and stdir um, catches any errors and also directs them to the screen. So how I would like to think about it is by using a water filtration system. STDIN is like the pipe that brings in raw water, which is the user input. SD out is like the clean water outlet where usable information flows out. And then ST error is like the waste pipe that discards the error separately. So ST out and ST error both appear on the screen, but Linux allows you to redirect these streams as they flow into different places. So you might be wondering what happens during redirection. So redirection in Linux works by rerouting the default path of these streams. Instead of displaying the output on the screen, it can be stored in a file or sent to another program or even ignored completely. So imagine you're watching a live news broadcast. Normally, everything the standard out and the standard error is broadcast to your screen. But if the program has an issue, you wouldn't want the audience to see errors mixed in with the news. But instead, the errors or the standard errors could be redirected to a separate control panel for technicians to fix. This is exactly how redirection works. ST out and ST error can be sent to different locations for better organization and control. Another example I can give you in this case is how phone calls work. So when you talk, your voice is sent to one person, which is the standard out. And if multiple people need to hear you, you can use a conference call, which is redirect standard out. And if there's background noise, it can be filtered out to another channel or to redirect at standard error. Similarly, standard input can be redirected so that instead of waiting for a keyboard response, the system reads instructions from a predefined source, such as a stored document. So here are some practical use cases. If a program encounters an issue, standard error can be redirected to a log file so administrators can review errors without cluttering the user screens, because who wouldn't want that? And then the data processing. So instead of like manually typing out an input every time, standard input can be preloaded from a file, which allows program to automatically without human interaction. So by controlling where data goes and how it's processed, Linux provides flexibility and efficiency in handling large-scale operations, whether it's managing logs, filtering informations, or automating tasks. In Linux, pipes act like conveyor belts, which allows data to flow from one program to another without needing to store it like a file first. So normally when you run a command, its output, which is standard out, is sent directly to the screen. But with pipes, instead of displaying that output, it becomes the input, which is standard in, for another command. This creates a seamless workflow where multiple programs can work together without manual intervention. So think of pipes like an assembly line. The command one provides or produces the raw data, which is known as standard out. Instead of printing it to the screen, a pipe passes it directly to as input, which is standard in, to command two, which refines or filters the data. You can chain multiple commands together, just like linking the machines in a factory, each one processing and improving the data before passing it on to the next. So you might be wondering here, why are pipes useful? It is efficient. So pipes eliminate the need to create and store temporary files, which keeps everything in real time. It also filters stuff, like you don't want to see large outputs, right? So large outputs can be narrowed down to show only relevant information, which reduces the clutter on the screen. And then you have automation, which pipes also allow complex workflows to run without user input, which makes them essential for scripting and system administration. So imagine you order coffee at a drive-thru. You place an order, which is also known as command 1 here, and the cashier sends your order to the kitchen, which is command 2. The kitchen then prepares the drink and sends it to the pickup window, command 3. And then you receive your coffee without stopping at each step, which everything flows smoothly from one stage to the next. This is exactly how Linux pipes work. Data moves from one process to another, which gets refined along the way, without unnecessary delays or storage. By mastering pipes, you can unlock one of the most powerful tools in Linux, which enables you to process information quickly and efficiently. Now we're going to demonstrate the stuff we learned. We will walk through user privilege, installation, command documentation, and system control in a real Unix environment. So let's start with user privileges. So in Linux, not all users have administrative access by default. So in order to perform these system level tasks, user either needs to switch into the root account or be granted sudo privileges. So let's see how it works. So you can see right now I'm logged in to user AYIC. Let's say I want to act as another user, Jack. So I can use the su command. So the su command in this case is follows the syntax su username. So in this case, I would use su jack. And then I type in its password. As you can see, right now I'm acting as like the user Jack. But I've inherited my previous environment settings. So if I want to switch environments as if I've logged in as a fresh, I can use su-username. So let's grant sudo privileges. So instead of switching users, a safer approach is by using sudo. So one way you can do it is by using vi sudo. Whoops, let me switch back real quick. So you can use sudo vi. So here's the file of the sudoers. I wouldn't recommend you to do this, but this is one way you can do it. But another way you can do it is by using the usermod command. So let's say you want to add a user to the sudo group. You can use the command usermod a capital G sudo a or Jack in this case, who we want to add to the sudo group. So you enter this command. Let's try doing sudo this time. And then in order for this to be updated, you do sudo apt update. Because when this user tries to run a command requiring root access, they can use sudo before the command now. Okay, so now let's try to install a package to see how the Linux packet management works. So we will install tmux, which is a terminal multiplexer that allows multiple terminal sessions inside a single window, which will be very important for this course. So to install tmux on Ubuntu, what you would do is use the command sudo apt install tmux. And then as you can see here, the system fetches the package, installs it, and once complete, we can verify it's installed by mentioning the program's name, which is tmux. And as you can see, the tmux has been opened. So let's work on finding documentation now, which is the man info and help page. So when working in Linux, you don't need to memorize every command because that would be super hard to do and nobody can really do it. So since you don't need to memorize every command, you have the documentation, which is built into the Linux terminal. So I'll show you how you can access it. So you can explore the man pages. For example, let's say you need help using the ls command. So let's do man ls. So as you can see, this gives us the detailed explanation or the information about the ls command and includes all the flags and options. So you can scroll through it using the arrow keys and then you can press Q to quit. And then you can use the info pages. So instead of using man ls, we can use info ls. So unlike man, info pages usually has hyperlinks like as you can see here to related topics, which makes the navigation easier. And then lastly, I would like to show you the help commands, which is for built-in commands. So let's say you need help using or knowing what cd is. So you can type in help cd and you can see here it is useful for shell built-in commands that might not have man pages. And then let's talk about system messaging and shutdown commands. And then let's say you want to broadcast a message to all users. So you can use the command wall and then let's say system maintenance will begin in 5 minutes. So what this does is it sends a message to all of the login users, which notifies them of important system events. In this case, how the system maintenance will begin in 5 minutes. So speaking of system maintenance beginning in 5 minutes, let's say you want to schedule a shutdown for 5 minutes. So in order to do that, you would use the command shutdown -8 plus 5 plus meaning however many minutes. So let's enter right here. So you can see that right now is 22:37. So you can see the shutdown scheduled at 22:42. So as you can see here, let's say you accidentally did it by mistake and you want to cancel the scheduled shutdown, it's easy. What you do is you just type in shutdown -C and then the thing is canceled. So let's say you want to just shut down now instead of waiting 5 minutes because you don't want to wait 5 minutes. So in order to shut down now, there's two options. The first one is shutdown H now, which is similar to the shutdown H plus 5 commands, but instead you use now. And you can see the machine shut down. And that's it for our demonstration. So in this video, we have covered the user management, software installation, finding command, documentation, and system controls, which are essential skills for any Unix administrator. And I would like to thank you for watching, and as always, stay secure and keep learning with CyberNetters.